Containerization in AIML project. Description. Containerization involves packaging an application and its dependencies into a container that can run consistently across different computing environments. In AIML projects, containerization ensures reproducibility, scalability, and ease of deployment. Benefits. Reproducibility. Description. Containers ensure that the AIML application runs consistently across different environments by packaging all dependencies. Isolation. Description. Each container runs in its own isolated environment, preventing conflicts between dependencies and libraries. Scalability. Description. Containers can be easily scaled horizontally by deploying multiple instances, enabling efficient handling of increased load. Portability. Description. Containers can be run on any platform that supports containerization, such as Docker or Kubernetes, ensuring platform independence. Simplified deployment. Description. Containerization simplifies the deployment process by providing a consistent runtime environment, reducing the chances of environment-related issues. Components. Docker. Description. A popular containerization platform that allows developers to package applications into containers. Key concepts. Dockerfile. Description. A script containing instructions on how to build a Docker image, including the base image, dependencies, and commands to run the application. Docker image. Description. A read-only template that contains the application code, runtime, libraries, and settings needed to run the application. Docker container. Description. A runnable instance of a Docker image, including the application and its dependencies. Docker Hub. Description. A cloud-based repository where Docker images can be stored, shared, and managed. Kubernetes. Description. An open-source container orchestration platform for automating the deployment, scaling, and management of containerized applications. Key concepts. Pod. Description. The smallest deployable unit in Kubernetes, representing a single instance of a running process in a container. Node. Description. A worker machine in Kubernetes, which can be a virtual or physical machine, running containerized applications. Cluster. Description. A set of nodes managed by Kubernetes, running containerized applications and services. Deployment. Description. An abstraction that defines the desired state of an application, including the number of replicas, update strategy, and rollback mechanisms. Service. Description. An abstraction that defines a logical set of pods and a policy for accessing them, enabling load balancing and service discovery. Steps to containerize AIML project. Step 1. Create a Dockerfile. Description. Write a Dockerfile specifying the base image, dependencies, and commands to run the AIML application. Example. From Python 3.8. Workdir app. Copy requirements.txt. Run pip install r requirements.txt. Copy. cmd python. main.py. Step 2. Build the Docker image. Description. Use the Docker CLI to build the Docker image from the Dockerfile. Command. Docker build AIML project. Latest. Step 3. Run the Docker container. Description. Use the Docker CLI to run a container instance from the built image. Command. Docker run dp 8080 is to 8080 AIML project. Latest. Step 4. Push the Docker image to a registry. Description. Push the Docker image to a container registry like Docker Hub for easy distribution and deployment. Commands. Docker tag AIML project. Latest your Docker Hub username AIML project. Latest. Docker push your Docker Hub username AIML project. Latest. Step 5. Deploy with Kubernetes. Description. Use Kubernetes to deploy the Docker container in a scalable and manageable way. Commands. kubectl create deployment AIML project. Image your Docker Hub username AIML project. Latest. kubectl expose deployment AIML project. Type load balancer, port 8080. Use cases. Training environments. Description. Containers can provide isolated environments for training models, ensuring consistency across different training runs. Model deployment. Description. Deploy trained models in containers to production environments, ensuring that the runtime environment is consistent with the development environment. Experimentation. Description. Containers can be used to quickly set up and tear down environments for experimentation, facilitating rapid prototyping and testing.